Hey guys, welcome to Solving Trig Equations Level 2. So if you watched the Level 1 video, what we did is, yes, we also solved trig equations, but they looked a little different. So if you look at the trig equations that I have around the screen, you'll notice things like, hey, these either have two trig functions in the same equation. There's squares floating around, there's a half angle floating around, there's a double angle floating around. So how do we deal with all of this? So that's why this is level 2. So here's some stuff that could come up while you're solving trig equations. The strategy surrounding all this like extra stuff that could come up, we're still trying to get the equation in terms of just the one trig function of the same angle. So the game we're going to try to play is like, how could I consolidate all this stuff that I have to just be one trig function? So how could I make this all cosines? How could I make this all sines? How could I just make this all the same trig functions? Because then we can use our factoring or our quadratic formula or, adding or subtracting things on the same side. And we're going to have to pull out our identities. So get ready to use your half angle formula. Get ready to use your Pythagorean identities. Get ready to use, your double angle identities, your reciprocal identities. We're going to use all of them. And then, like I said, factoring a quadratic formula. And then, of course, we have to consider all values. So we're going to still add 360k, add 2 pi k, and go from there. So here's our first example. 8 sine x minus 4 cosecant x equals 0. So this is a little different, right? Because, okay, I can't combine these because that's a sine and that's a cosecant. But maybe I can transform these into each other. Well, luckily, sine and cosecant are reciprocal partners of each other. So I can actually rewrite this. 8 sine of x minus 4 times 1 over sine of x equals 0. Now, everything is in terms of the same trig function, right? Because I transformed cosecant into sine by using the reciprocal identity. Let me get sine on the same side, on opposite sides. 8 sine of x equals, I'm going to add this term to both sides. I'm also going to put the 4 in the numerator. 4 over sine of x. Why am I doing this? Because I'm going to multiply both sides by sine of x to get it out of the denominator. Right? These guys cancel, get it out of the denominator. I'm left over with a 4 on the right side. On the left side, I'm with 8 sine squared of x equals 4. Okay? Let's divide both sides by 8. Divide by 8. Divide by 8. I want to get sine squared by itself. So I got sine squared of x is equal 4 over 8 is equal 1/2. Great. I don't want sine squared, though. I want sine. So which means I need to undo the square by taking the square root. When we take the square root, we'll pop out with sine of x. Perfect. Remember, when you take the square root of something, it's either the positive version or the negative version. So sine of x is going to be equal to square root of 1 is 1, square root of 2 is square root of 2, and it's the plus and the minus version. This is equal to, if I rationalize the denominator, root 2 over 2 or negative root 2 over 2. Again, when you square root something, remember you get the positive negative version. So the question is, where does sine of x equal either positive root 2 over 2 or negative root 2 over 2? Well, that's at every single 45 degrees. So that's going to be 45. That's going to be 135. That's going to be 225. Or that's going to be 315. And all of these, of course, get the plus 360. Okay, in radians, that's pi over 4. That's 3 pi over 4. That's 5 pi over 4. And that would be 7 pi over 4. All of those individually, we would say plus 2 pi. Okay, because sine repeats itself every 2 pi. Okay, so what did we do here again? We hit this with the reciprocal identity, got everything in terms of sine solved for sine, hit everything with the square root because we had sine squared equals number. And remember, when you hit something with the square root, you have to include the positive and negative version of that number, which is why we got all 4 kind of marks on the unit circle here. Okay, let's look at our next one. So cosine of 2 theta plus 3 sine theta minus 2 equals 0. The initial issue that we have is like, hey, there's a cosine and there's a sine. I want this all in terms of one trig function. Well, if you notice cosine of 2 theta, right, I can hit this with a double angle identity, and I want to turn everything in terms of sine. So if you look at the double angle identity for cosine, right, we have 3 to choose from. The one we're going to choose is the one that has sine in it. So cosine of 2 theta, I can transform into 1 minus 2 sine squared theta, which is what we're going to do, because then that will knock out this, and I can have everything just in terms of sine. So let's do that. So cosine 2 theta becomes 1 minus 2 sine squared theta plus 3 sine theta minus 2 equals 0. Okay, let's consolidate some stuff. Like I have a 1 over here and I have a minus 2 over here. Negative 2 sine squared theta plus 3 sine theta. 1 minus 2, negative 1. So I combine the negative 2 and the positive 1 together. These guys equal 0. Hey, it looks like I have a quadratic where negative 2 is my A, 3 is my B, negative 1 is my C. Let's throw this guy into some quadratic formula. So we're going to solve for sine theta here. So then sine theta would be negative B plus or minus the square root of B squared minus 4 times A times C. All of this is over 2 times A. Okay, let's simplify. 3 squared is 9 minus negative 2 times negative 1, positive 2. Positive 2 times 4 is 8, so this would be 9 minus 8 up here. 2 times negative 2 is negative 4. Conveniently, 9 minus 8 is 1. Oops, I forgot the plus minus. 9 minus 8 is 1, and the square root of 1 is 1. So this is going to be negative 3 plus or minus 1 over negative 4. So sine of theta then is going to equal negative 3 plus 1 is negative 2. So plus 1, negative 2 over negative 4, that'd be positive 1/2. Or negative 3 minus 1, that'd be negative 4 over negative 4. That's going to give me a positive 1. So sine of theta equals 1/2. Then theta is equal to 60 or 120. And then, of course, this is plus the 360k, both of these. In radian measure, pi over 3 or 2 pi over 3. Plus, and this would be plus 2 pi k. Each one of these would be plus 2 pi k. I'm just lazy and shorthanding it over here. Or 1, so sine theta equals 1. The only place where sine of theta equals 1 is at, in degrees, 90 plus 360k. In radians, that's pi over 2. Plus, I almost wrote 360 plus 2 pi. Okay, there we go. So we used identities to get this whole thing in terms of sine, and then we used quadratic formula to solve for sine, set it equal to the 2 values we got when we solved quadratic formula, used some unit circle magic here, and we got our 1, 2, 3 solutions. All right, let's see something else. Okay, what about 2 cosine squared plus sine minus 1 equals 0? What do we do with this? How can we transform, let's use white. How can we transform one of these guys into the other? Well, for this particular equation, and in fact, a lot of the times when you have to relate sine to cosine, we use the Pythagorean identity that sine squared plus cosine squared equals 1. This is how sine and cosine relate to each other. So whenever you have to transform one into the other, the most common strategy to use is to use this Pythagorean identity. Well, I have a cosine squared, so let me subtract sine squared from both sides. So cosine squared of x then will be equal to 1 minus sine squared of x. So now I can take this and I can sub it in here, right? Because cosine squared of x equals 1 minus sine squared of x. So instead of cosine of x, I'm going to sub. So the 2 out front stays. 1 minus sine squared of x plus sine of x minus 1 equals 0. And now, through relating sine and cosine through the Pythagorean identity, I have transformed cosine squared into sine squared, and now I have an equation of just one trig function instead of 2. And so again, that's the strategy. How can we transform this equation into just one trig function? Distribute the 2. 2 minus 2 sine squared x plus sine of x minus 1 is equal to 0. Negative 2 sine squared x plus sine of x. Negative 1 and 2, combining these together, will be positive 1. All right, again, it looks like I have a quadratic. Let's hit this with some quadratic formula. Negative 2 will be my a. 1 here will be my b. 1 will also, looks like, be my c. So sine of x then is going to be equal to negative b is 1, negative 1 plus or minus the square root of b squared, b is 1, minus 4 times a times c. All of this is going to be over 2 times a. And we simplify. Negative 1 plus or minus the square root. 1 squared is 1. 4 times negative 2 is negative 8. So 1 minus negative 8 then up here over negative 4. So we have negative 1 plus or minus 1 minus minus 8. That'll be 9. Square root of 9 is 3 over negative 4. Okay, so we're going to have either negative 1 minus 3, negative 4 over negative 4. So we get a positive 1 again. Or negative 1 plus 3 is 2. 2 over negative 4 will give us negative 1 half. So this is going to look kind of familiar. So we have sine of x equals 1, as we saw previously. Then x equals 90 or pi over 2 in radians or degrees. And then, of course, if you want all angles, write plus 360k. If you want all angles, write plus 2 pi k for this guy. Our other solution was negative 1 half. For negative 1 half, then, x would equal 300. Or, if we hit it on the reflection, that would be 240. And then in radian, then instead of pi over 3, we would hit the reflection with that guy, pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, 5 pi over 3. And then 240 is 4 pi over 3. And then these guys would be the plus 2 pi k. And these guys up here would be plus 360k. So again, what did we do? We hit this with Pythagorean identity to transform cosine squared into sine squared, 1 minus sine squared, by using the Pythagorean identity. Then we had an equation all with one solution. Sorry, an equation with one trig function. We threw it into quadratic formula, and we got our solutions that way. And our last example is going to use half angle formula. So for the half angle formula, so we're still trying to do the same thing, right? I have a sine of theta over 2, and I have a cosine of theta Now, I want to get this all in terms of the same trig function as well as the same angle. How can I transform sine of theta over 2 into something with terms of cosine? Well, if we look at our half angle formula for sine, right, this is equal to plus or minus the square root of 1 minus cosine of theta over 2. So let me transform that then. I'm going to stick with the plus and minus right now. And I know it's weird, but just hang with me. 1 minus cosine theta over 2 plus cosine theta equals 1. Okay. Everything is in terms of cosine theta. That's what I want. What I really need to do is I really need to get rid of this square root. Well, how do I get rid of a square root? Well, I square it. Well, I don't want to square it unless this term is isolated. So let me get rid of the cosine theta over here. So I have plus or minus square root 1 minus cosine theta over 2. Subtract cosine from both sides, 1 minus cosine theta. I have isolated the square root. Now, what I'm going to do is I'm going to square both sides. This not only takes care of the plus or minus, right, because a negative squared becomes positive, a positive squared also becomes positive. So this square not only knocks out this square root, it also knocks out this plus minus issue here. And in doing that, we end up with 1 minus cosine theta over 2 on the left. On the right, 1 minus cosine squared, let's distribute out. 1 minus cosine squared is 1 minus cosine times 1 minus cosine. So we would have 1 times 1, which is 1. 1 times negative cosine, which is minus cosine theta. Minus cosine theta times 1, which is minus cosine theta. And minus cosine theta times cosine theta plus cosine squared theta. Let's combine our right side. Negative cosine minus cosine, this is minus 2 cosine plus cosine squared theta. 1 minus cosine theta over 2. I want to get rid of this over 2 over here. We multiply everybody by a 2. So this will be, these guys now will cancel. I'll have 1 minus cosine theta on the left. Multiply by 2, so this will become 2 minus 4 plus, 2 cosine. 4 cosine theta plus 2 cosine squared theta. Now we have a quadratic, and so what game do we play when we have a quadratic? We get everything on one side and we get a 0 on the other side. So I need to get rid of the 1 and I need to get rid of the cosine theta. 1 and negative 1, positive, negative. So that will cancel out and I'll get a 0 on my left. On my right, I subtracted 1 from both sides, so 2 minus 1 is 1. I also added a cosine theta. So I have negative 4 cosine theta. If I add a cosine theta, I would have negative 3 cosine theta plus 2 cosine squared theta. Let's reorganize this so it just looks a little more familiar. 2 cosine squared theta minus 3 cosine theta plus 1. Okay, quadratic equal to 0. Perfect. Let's throw it into quadratic formula. 2 is A, negative 3 is B, and 1 is C. Perfect. Let's put it up here. So we have cosine theta then is equal to negative B, so that'd be positive 3 plus or minus the square root of B squared. Negative 3 squared is 9, minus 4 times A times C. All of this is over 2 times A. So cosine theta is equal to 3 plus or minus 9 minus 8 is 1. Square root of 1 is 1. So plus or minus 3 plus or minus 1 over 4. So we get cosine of theta is equal to 3 plus 1 is 4, 4 over 4 is 1, 1, or 3 minus 1 is 2, 2 over 4 is 1 half. So if cosine theta is equal to 1 or 1 half, so again, unit circle, if cosine theta is equal to 1, then theta is equal to 0 plus 360 k, or 0 plus 2 pi k. And then if theta is equal to, or sorry, if cosine theta is equal to 1 half, then that's 60 degrees, or, excuse me, not 120. So if cosine theta is equal to 1 half, then we have 60 degrees, or we have 300 degrees. And then this is all going to be, of course, plus 360k. In radians, 0, or pi over 3, or 5 pi over 3. Okay, so we took the half angle formula. We went through a lot of algebra. After turning this into the half angle formula, this is all algebra, again, up until we're solving for cosine, and then we roll out the unit circle again. But most of this solving is still algebra, using the algebra tactics that you know back when you were still solving for x and not solving for cosine or solving for sine or solving for tangent, okay? So I will say that you do need to be pretty steady on your algebra skills to do stuff like that, because you can see it gets like a little bit complicated and complex, but it's nothing that you haven't seen before. And that was the last example. So we saw a couple more variations of trig equations. There's going to be one more video for trig equations because we have to look at even some more variations of some stuff that can come up. But now you know how to deal with a trig equation if you have to hit it with an identity to then get it in terms of all one trig function and then solve it using factoring, quadratic formula, or just, you know, plain old equality. Okay? As always, if you guys have any questions, please don't hesitate to ask.